Hello friends, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today I am going to talk about naphthalene. So first I will discuss about the uses of naphthalene. So here listed uses of naphthalene. First one, naphthalene as mothballs has been used to protect woolen goods from moths. It is also used for increasing illuminating power of coal gas. Naphthalene is used in manufacturing of phthalic anhydrides, carbyle for insecticides, to naphthol, dyes, and some medicinal products. Propranolol, antihypertensive drug. Tolnafthate, antifungal. Menadione, vitamin K, and naphthozoline, vasoconstrictors for rhinitis and sinusitis. Now friends, I am going to show you substituted naphthalene via Haworth synthesis. Uses substituted benzenes. You can see here the toluenes. This compound react with toluene, forming these products, and after several steps you will get this beta. Second one, if you have Grignards, then you can form this, and this product easily react with RMGX and attack on this CO, and then remove water in acidic, forming this, and then palladium carbon dioxide after heating alpha products. You can see here this, then ester, then RMGX and water. You can see OHR, and then heat, double bond formation, then CO2, cyclizations, then finally you will get this products. So reactions of naphthalene: oxidations in presence of chromium oxide, acetic acid at 25 degrees Celsius. You have to maintain this temperature during your reactions. You will get the 1,4-naphthaquinone. This is ring benzene and this is hydroquinones, so combined together 1,4-naphthaquinones. And this one react with this naphthalene, undergo oxidations, vanadium pentoxide, and you have to maintain too much temperature. It will give the phthalic anhydrides. Now friend, oxidations. Oxidations by vanadium pentoxide is important industrial process. Naphthalene is available from coal tar. Vitamin K1, K2 are derivatives of 1,4-naphthaquinone. Because of this tendency to form quinone, it is not always feasible to prepare naphthalene carboxylic acid by oxidation of methyl side chain. Now friends, you can see naphthalene is sensitive to oxidation. You cannot make naphthoic acid via oxidations of side chain. You can see this oxidation happened on this ring. You see these groups converted into acids. Now friend, reductions. There are 3 steps of reductions. In the presence of sodium in ethanol at 78 degrees Celsius, you will get 1,4-dihydronaphthalene. In presence of sodium isopropanol and 132 degrees Celsius, you will get tetrahydronaphthalene, tetraline. And then in presence of H2O platinum high pressure, you will get decalines. Now reactions of naphthalenes. Electrophilic substitution reaction. So I will discuss about the Fry's rules. The most stable arrangement of polynuclear compound is that form which has the maximum number of rings in the benzenoid conditions. 1 substitutions versus 2 substitution. Number of resonance structure. Aromatic state is related. Benzene has large resonance structure. Now friend, carbocations in transition state resulting from attack at the 1 position are much more stable than those resulting from attack at the 2 position. Therefore, 1 substitution will be preferred. You can see the nitrations, 1 nitronephthalene, sulfonations at 80 degrees Celsius and 160 degrees Celsius. On 80 degrees Celsius, you will get the SO3H at 1 positions, and at 160 degrees Celsius, you will get 2 position SO3H. Halogenations in presence of molecular bromine and carbon tetrachlorides, no catalyst required. Now Friedel-Crafts alkylations, you can see polyalkylations, Friedel-Crafts acylation, you will get in non-polar solvent 1 positions, and nitrobenzene solution you will get the 2nd positions. Now friends, alpha substitution via halogenation or nitrations. You can see Br2 forming 1 bromonephthalene and then magnesium naphthalene magnesium bromide. Nitrations at 1 positions and then NO2 group reduced to NH2 groups. Beta substitution via high temperature sulfonation of Friedel-Crafts acylation in nitrobenzene. You can see the SO3H converted into sodium oxide and then acidic, you will get the naphthol, and further reductions of OH, you will get the amines. So how SO3H converted into Na and then OH, and then OH converted into NH2. Then you can see if you have the COCH3 undergo oxidation forming the acid and then thionyl chloride amide, and from amide you will get the NH2. So this is the summary of naphthalene reactions. You can make the naphthol SO3H group 2 position, SO3OH 1 positions, NO2, NH2, NY, and so on. Now friends, I will talk about the anthracene. You can see the numbering scheme in anthracene. 9-10 positions, important. And this is the resonating structure. You know friends, heat of hydrogenation is 84 kilocalorie lower than expected. 2 into 36 is equal to minus 72. So minus 82 minus 72 is equal to minus 12 kilocalorie per mole to remove the middle rings aromaticity. So phenanthrene, you can see the numbering scheme. This is angular, 14 pi electrons. Total 5 resonating structure. Heat of hydrogenation is minus 92 kilocalorie per mole, lower than predicted. You can see of the other middle. Now friends, ELB synthesis. The conversion of diaryl ketone containing a methyl or methylene groups ortho to the carbonyl function is known as ellipse reactions. When orthomethyl benzophenan is heated at 450 degrees Celsius, anthracene is formed. You can see the starting compounds and the product. Now friends, Friedel-Crafts reactions. Benzyl chloride react with itself to form 9,10 dihydroanthracene, which readily loses 2 hydrogen atoms to yield anthracenes. So you can see here benzyl chlorides combine together in presence of acid and the products. Now friend, Diels-Alder reaction. Naphthaquinones react with 1,3-butadiene. You know this is formation of adduct. It reacts with chromium oxide. You see the oxidation occurs in zinc, then it makes the anthracene. Now, Hauer synthesis of anthracene, benzene, silicon anhydride, LCl3 forming 2-benzoyl benzoic acid. With sulfuric acid, you will get anthracene, 9,10-di-1, and then zinc amalgam, both CO converted into CH2, 9,10-dihydroanthracene, and in case of platinum CO2 heat, you will get the anthracene. So friends, Hauer synthesis of phenanthrene, naphthalene, succinic anhydride, you will get 5-naphthalene, 1-allyl 5-oxopentanoic acid, zinc amalgam HCl, you will get 4-naphthalene, 2-allyl butanoic acid, react with sulfuric acid, cyclization occurs, 2,3-dihydronaphthalene, and this CO converted into CH2 in presence of zinc amalgam, you will get 1,2,3,4-tetrahydronaphthalene, and then palladium and carbon dioxide, you will get this reduced product, oxidized product. Now oxidations, you can see 9,10-anthraquinone and 9,10-phenanthrone. You can see in the presence of sodium, reductions occurs, 9,10-dihydroanthracene, here 9,10-dihydroquinones and dihydrophenanthrene. Now, this is the summary of how sulfonation, nitrations, chlorinations, acylations at anthracene. You see the electrophilic substitution of phenanthrene, acylations, nitrations, chlorinations, and sulfonations. So reactions of anthracene, you can see here reactions of phenanthrene. So this is the Hauer synthesis. Now I will talk about the uses of anthracene and phenanthrene. Anthracene, synthesis of anthraquinone. Anthraquinone is used in manufactures of elizarines and several other dyes. Purgative drugs, senna, rhubarb, cascara, dithrol, antifungal. Beta-phenanthrene is used as carcinogenic. Steroid moiety contains phenanthrene nucleus. Sex hormone, bile acid. Steroid used as an oral contraceptive and anti-inflammatory agent. Cardiac glycosides, morphine, codeine. Now you can see synthesis of diphenylmethane. So if you have these two compounds, you make diphenyl. Synthesis of diphenylmethane also possible. So derivative of diphenylmethane, you can see the benzophenone and benzhydrol. Use of diphenylmethane and triphenylmethane. Diphenylmethane polymer synthesis of acetaminophen dyes, synthetic steroid, benzophenone, diphenyl carbinol, fluorine, and malachite grain, crystal violet, and other dyes. So reactions of diphenylmethane, reaction of triphenylmethane. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.